Nitrogen is an essential ingredient in DNA, RNA, and proteins. Nitrogen gas makes up 78% of the atmosphere, but is chemically inert and cannot leave the atmosphere without assistance. Under the right conditions, nitrogen can become biologically active and enter the biosphere and lithosphere through the nitrogen cycle. To become biologically available, nitrogen fixation will combine nitrogen with hydrogen to form ammonia, whose water-soluble ions of ammonium can be taken up by plants. Nitrogen-fixing bacteria convert nitrogen gas into ammonia. The bacteria form nodules on plant roots, absorbing sugars from the roots in exchange for nitrogen fixation. Some of these bacteria are found in legumes like soybeans. Other bacteria perform a process called nitrification, which converts ammonium ions into nitrite ions and then into nitrate ions, which plants can directly take up. These ions are also added to the soil through the use of fertilizer. Consumers obtain nitrogen by ingesting plants or other animals. Decomposers obtain and release nitrogen from dead and decaying matter. Denitrifying bacteria will then convert nitrates back into nitrogen gas, releasing it back into the atmosphere and completing the cycle. Nitrogen fixation has historically been a bottleneck, a step that limited the flux of nitrogen out of the atmosphere. The Haber-Bosch process enabled people to artificially fix nitrogen, which greatly enhanced agriculture. Humans have effectively doubled the rate of nitrogen fixation on Earth. Runoff can cause excess nitrogen to enter waterways, which leads to eutrophication. Burning fossil fuels also releases additional nitrogen into the atmosphere.